Hello, this is day 2 of sum and difference formulas. We've discussed different trig identities and sum and difference formulas. For this lesson, we're actually going to find the sum and difference for different angles given two separate trig ratios for two completely different angles. All right, I'm sorry, I forgot to return the 1. So this is 1. Sorry, the 1 should be here, so not to confuse you. So there's two different angles in two different quadrants. So the first thing we're going to do is actually draw this angle in the correct quadrant. So I have in the quadrant, the angle alpha is between 0 and pi over 2, so that's going to be the first quadrant. And sine is opposite over adjacent, so this is 4 and this is 5. And then to complete it, we're going to have to find this, and this is the Pythagorean triplet. It is 3, 4, 5. If you didn't know that, you can use the Pythagorean theorem. All right, for our second angle, it's beta, and it's going to be in, what quadrant is that? So we're going negative, so that's that direction. So that's negative pi to negative 3 pi over 2. So that's going to be our third quadrant. So beta is here. So adjacent over hypotenuse. So it's going to be negative root 2 for adjacent and 5 for the hypotenuse. We need to find the opposite. The reason why we're filling it out, because, one moment, when we're looking at our formulas, we're going to need the sines and cosines of each of the different angles. So we need both legs for that. So to find this leg using the Pythagorean theorem, okay, so this is going to be 2. This is going to be 25. So it's going to be, x is going to be the square root of 23. Now it's in the third quadrant, so this is going to be negative. So I'm going to use these two triangles to help me find these different things. And yes, this is what your homework is going to look like. For each problem, you're going to have 4 different parts. They're not necessarily hard parts, but they will take a little bit. But if you have your 2 triangles all written down and completed, it'll be much quicker. All right, so we're going to find the sum of alpha and beta. So we're going to use this formula. Okay. So sine of alpha. Well, sine of alpha, right? So we're looking here. So sine of alpha is 4/5 times the cosine of beta, which is negative root 2 over 5, plus the cosine of alpha. So looking at, looking at this triangle, alpha is adjacent over hypotenuse, so that's going to be 3/5 times the cosine of beta, which is over here. Did I have that right? Sorry. The cosine of, alpha, the sine of beta. So the sine of beta is on this side. So this can be negative root 23 over 5. So I'm going to multiply the numerators, the denominators. So you can see I have a common denominator, 25. And then I'm going to just write down each numerator here. They're not the same root, so I cannot combine them. So this is just going to be our final answer. All right. Now, it says to do B, but I'm actually going to do C. adjacent. Can you guess why? That's right, because it's identical to the sum, but it's just the sign is different. So we're using this one. So you can see the sine of alpha, cosine of beta, that's the same. Cosine of alpha, sine of beta, it's just the signs are opposite. So this is actually going to be the same. This is going to be the same. This is going to be the same. Oops. But I made that the same. That's the one thing that's going to be different. It's going to be subtraction. Okay. So I know the denominator is 25, so I'm going to go straight to that. And I know really it's going to be the same thing as this. But the negative and the negative is going to turn positive. And then this is our answer. So it is almost identical to this one, but you can see the signs changed. All right. So I'm actually going to erase this, and then I'm going to do B and D. Now, if you need to rewind to see any of it, you can. Also, if you want to press pause and try to do cosine on your own, you're more than welcome. Okay. So we're going to do B now, which is cosine of alpha plus beta, which is this one. Okay. So for that one, we're going to use cosine of alpha, which is 3/4. And cosine of beta, root 2, negative root 2 over 5, minus sine of alpha, which is also over here, which you can also look down here, times the sine of beta, negative root 23 over 5. All right, so one of these are wrong. I think it's this one. The cosine of alpha should be 3/5. I wrote 4. You probably actually knew that. Okay, so the denominator should be the same, so it's 25. 3 root 2, negative and negative positive, 23. Okay, there we are. All right, tangent. So tangent of alpha plus beta. So we are going to use this one. So tangent of alpha is 4/3 plus tangent of beta. Okay, that's going to be negative root 23 over negative root 2. So that actually is going to be a positive over 1 minus tangent of alpha times the tangent of beta. So you're just multiplying these two. All right. So I'm going to need a common denominator. So I'm not going to completely simplify it, but this is a complex fraction, which means you have a fraction of fraction, and we do not leave those. So my common denominator is 3 and root 2, and you can say 3 and root 2. So I'm going to multiply this by root 2 and this by 3. And then for this one, I'm going to change it to root 3 over 2 to have the same denominator of that. So I'm going to change this to that. So that's going to look like this. Over 3 root. Okay. Now you can see there's both 3 root 2's in the denominator. So they're going to simplify out. It's like multiplying 3 root 2, 3 root 2. I'm going to simplify out. Okay, and we're going to leave it like this. You're going to say, oh, shouldn't we rationalize the denominator? For these problems, we can just leave it like this. As long as it's not a complex fraction, I'm going to be okay with that. All right, so we're going to do this problem, but we're only going to do here these two. I just want you to practice actually writing the two triangles that you're going to be using. So this first one, this time we're given tangent. And let's look at the quadrant. Okay, so the tangent, we're from pi to 3 pi over 2. Third quadrant, alpha, opposite over adjacent. Some of you may know this is the Pythagorean triplet, and this is 13. You can also use the Pythagorean theorem, a squared plus b squared equals c squared, and find the hypotenuse to be 13. For this one, all right, it says negative pi over 2, that's here, to 0. So that's going to be the fourth quadrant. And it's going to be negative 1 over 4. So this one I actually don't know. So it's going to be x squared, negative 1 squared is 1, 4 squared is 16. So it's x equals the square root of 15. Right, and then I'm going to look at my formulas. So we're going to do sine, which is this one. All right, so I have sine of alpha plus beta. So we're going to look at our triangle. Oops, I also forgot they're both negative. That's important. That will change our sine and our cosine. So sine of alpha is negative 12 over 13 times cosine of beta, which is root 15 over 4, plus cosine of alpha, negative 5/13, and sine of beta. Okay, so denominator is going to be the same. 13 times 4, I believe, is 52. Okay, is it negative? So this is negative, so it's going to be negative 12 times root 15. Negative and negative is positive 5. And then we're going to do cosine sum. All right, so the cosine sum, it's going to be the top one. So the cosine of alpha, it's over here, times the cosine of beta, which is root 15 over 4, minus sine of alpha times sine of beta. Sorry, I forgot. So that's negative 5 root 15 over 52. Negative and negative is positive, but I still have that. So it's negative. Okay. Again, I'm not going to do C and D. All right. Establish the identity, a proof. So this proof is a little bit different in that they actually give you a number here. It's pi over 2, which is 90. And if you can see this, this is actually a sum. And so that we can use our sum and difference formulas. So we're going to use one of the sum formulas. And we are going to use this. We're just going to do what it says. So this is going to be alpha, and this is going to be beta. So sine of alpha, pi over 2, times cosine of beta, which is theta, plus cosine of alpha, which is pi over 2, times the sine of beta, which is theta. Okay. Now, I can evaluate this. I can actually find the value of it. Evaluate, find the value. Writing our point, pi over 2 is here. This is a 0, 1. This is our sine, and this is our cosine. So sine of pi over 2 is 1 times cosine theta. I don't know the value of theta, so we're just leaving it as theta. Plus the cosine of pi over 2, that's our x value, which is 0, times sine theta. So 1 times cosine theta is cosine theta. 0 times sine theta is 0. Add that, and you get cosine theta, which is the same as the right side. Voila, true. Right? So using the sum formula, or maybe you'll have a different formula to use. You just use this, write it out, and then just evaluate and then simplify. Right. Don't forget to do the problems on your own. Make sure they're in your notes. I've given you 2, to do, cosine and tangent. Make sure you write and draw the 2 triangles. And don't forget to answer the EQ. Thank you so much for watching. Bye.